This session, we will be answering some question regarding the big O notation. But before we do that, we need to look at the definition. So what it means to say that a function is bounded above asymptotically by another function g. And the definition that frame this relationship goes like this. Let f and g be function from the set of integer to the set of real number. We said that f of x is big O of x if there are two constants c and k such that this inequality applies whenever x is greater than k. There's a lot of said in this definition. We need to rephrase it in some concise way so we can understand exactly what we are looking for when we attempt to answer question regarding this finding or showing that a function is a big O of another. Here's the rephrase of the definition. This is the first one, and this is the second one. This is a second order quantification over function, but I'm gonna follow the second one. Is really simpler. So this is the equivalence relation. So this is when we define something. So we say f, the function f, is a big O of g if and only. So that means if this is the case, then this follow. And if we know this, then it is the other way around. So here the definition said there exists a c and there exists a k, and for any x, if x is greater than k, then the inequality hold. All right. So now when we answer this, when we answer a question like this, what does really mean? Let's look at some other example that we maybe understand well, which is something like this. So let's say we're talking about the set of real number, and we have this statement. Okay, what it really says, there exists k such that for any x, x plus k equal to x. So to prove this, we need, this is existential proof. What it really says, you need to find at least some value for this so it really holds. And to answer that, we can choose k to be equal to 0. All right. So when we choose this one and choose k equal to 0, we know that, and then we instantiate the universal quantifier. So let's say give it any value, say a, then a plus 0 is equal to a. So in other words, I could have chosen anything, is always the case. So what this really statement says, that talking about the 0. The 0 is the identity element. So anything plus that thing x, k, in this case 0, is that thing. So how we answer that then is just we picked a value. We say, all right, this one really hold for at least one value, in this case 0. And in fact, in this example, there is exactly a unique one value, but that's not of concern to us here. So k equal to 0 is a solution. All right, so we go back to our definition of the big O notation. So what that means, in order to answer a question of this format, we need to find values for the c and for the k. And if we do that and the inequality hold, then we just succeeded. So we're going to see some example that use this technique. All right, there's an example. So this is my f. This one is my g. I'm going to rewrite it here. G of x equal to x squared. Okay, so we're going to appeal the definition. Remember the definition said there exists c and k, and for every element if x is greater than k, then the inequality hold, which is really just say there are some constant c, which is a multiple constant multiple of this function. This is less than or equal. Okay, so we're going to use a method that we discussed in class, which goes like this. I'm going to write the function. I'm going to write f of x less than or equal. I don't need to use the absolute value because we are dealing with positive valued function. So I'm going to drop the absolute value. So what we need to show, what really we need to show that this relation hold. Okay, so this is just to show, to remind us what we are going to do. Right? I'm gonna just write it here between square brackets to indicate this is not, we are not begging the question. We just say this is our plan. So I'm gonna rewrite the values. So I'm gonna write f of x. F of x is just x to the 2 plus 2x plus 1 and less than equal c. I still don't know what the c, I'm gonna find it. And g of x is just x to the 2. From this, what I will do, I'm gonna divide both sides by g, by x to the 2. All right, so when I do this, I'm gonna get 1, because x to the 2 by x to the 2, it's 1. And then here I have just 2 over x plus 1 over x to the 2 less than or equal c, just c. Right? What I did here, I just divided by x to the 2. Give me this. All right, so then what I will do, I'm gonna go and find the limit for this part. So I'm gonna say the limit of 1 plus 2 over x plus 1 over x the 2, okay, as x goes to infinity. So what the value here, when x go to infinity, these two will be 0. So 0, what is left is really 1. So we go back to this equation. This means that one. It means just 1 is less than or equal to c. Okay, since this is a limit, I'm gonna choose c to equal to 2. Now we find next we find k. So remember here we need to find these two. We need to find the c and k. We just found the c, now we find the k. How I'm gonna find the k? We're gonna do it this way. So we're gonna go back to this equation here, right? But now I have the c. C is equal to 2. So we have now x to the 2 plus 2x plus 1 less than or equal 2 times x to the 2. From this, it follows, I'm going to use arrow to mean it follows, right? I can just add negative 2x negative 2x squared to both sides. So when I do this, I'm going to end up with this value. I'm going to have then minus x to the 2 plus 2x plus 1 less than or equal to 0. If I multiply both sides by negative 1 just to make this one positive, then I will have something like this: x to the 2 minus 2x minus 1 greater than equal to 0. Then from this is become now a quadratic. I can use the quadratic formula to find the x. So go ahead, I'm not going to do it here. Go ahead and use the quadratic equation to solve it. This is now the a is 1. Okay, to find the quadratic equation, a equal to 1 and b equal to -2 and c equal to 1. When you do that, you will find some values. One of them is just say that x equal 2 point some small number equal 2.4 whatever, some number. So in this case, just to be safe, I'm gonna choose x to be 3. All right, so my final answer then will be just we're gonna make the, I'm gonna write here I'm gonna use different color. All right, I'm gonna make the answer then is here in the equation, c is equal to and k is equal 3. And if you graph it, or you can check that is really the case. If you plug the values from starting from value from after 3, you will see this equation is really hold. If you want to double check, you can plug the information here. So if you can plug 3 or more, because remember the definition says whenever x is greater than k, so greater than 3, but we choose a number that's enough. So if you plug here, we have what, 3 to the 3, this is 9, and here 2 times 3 is 6 plus 1. So this size is equal to 16. So it's better, this side, the left hand side is better be bigger than that. So we know that c is equal to 2, and then we have x, which is 3. 3 times 3 is 9. Then 2 times 9 is 18. So in fact, this is correct, because 16 is less than or unequal 18. So that confirms the correctness of our choice. And recall that in class also we mentioned these two constants are not unique, and it should be evident from the definition. Our understanding of the existential quantifier, when you have something like this, there exists c and k, it doesn't mean they are unique. It means could be at least 2, but could be more, could be even infinity of them. And this follow from the meaning, follow from the semantic of this quantifier. So any values, when we find pair of these, we can choose other. So for example, I could have now choose c equal 3 and k equal 4. This will work. Just keep increasing. We try our best to have some conservative choice. What that means, you choose a smaller number. But at this point, as long as the inequality hold, we are okay with it. Here is a second example. So we still in the case of proving that some function is a big O of another. In this case, we want to show that f is big O of g. We're going to do the same technique. So we're going to write the two functions. So we have the first function f, 3x to the 2 plus 10x plus 7, which is less than or equal. C is the constant we try to find. And then we write the g f x to the 2. From this, what we can do, we can divide both sides by x to the 2. So when we do that, I end up with just 3 there plus 10 over x plus 7 over x to the 2 less than or equal to 5. So I just here, the reason for this is I divided by x to the 2. And notice I can do that. Why? Because x is greater than 0. So it's fine. So it's not negative, it's not 0. Alright, next, what I will do, I have this now. So I'm going to take the limit for this part. So I'm going to say, alright, so get the limit as x approach infinity for the term 3 plus 10 to x over 7 over x squared. When I do that, these two terms will be infinitesimally small. So this will be 0, this will be 0, and the limit will be just 3. All right. So when this one is 3, then I end up with something like this: just 3 less than or equal to. This should be here C 5 C. Okay, and it follows from this, it follows that C is greater than or equal to 3 over 5. So what we will do then, we're going to say C is equal, because this one is less than 1, we're going to make C equal to 1. So this is my first value. All right. Now next, I'm trying to find K. I need to find K. What is K? So since I found the C, it should be easy to find the K. So I'm going to go and substitute in this equation here, but this one with the information that C, I know what C is. So let's write it here: 3x the 2 plus 10x plus 7 less than or equal 1. I'm going to write the 1 here. 1c, 1, what should the value of c? 5x to the 2, which is really just 5c. Just remind us we got the value. Okay. So I'm going to add negative 5x to both sides. When I do that, then this will move here, and it will be something like this: negative 5x to the 2 plus 3x to the 2 plus 10x plus 7, and this one less than or equal to 0. And this will be simplified. I'm going to get there negative 2x to the 2 plus 10x plus 7. This one greater than, less than or equal to 0. I can go ahead and multiply. So if I want to make these to be positive, multiply both sides by negative 1. So it will give me 2x to the 2 plus 10x. So negative, so it will be negative x, and negative 7 greater than or equal to 0. So this is the second degree equation. So that means the quadratic, I can use the quadratic equation to solve it. And when I plug the values, so the A will be 2, B will be negative 10, and C will equal to negative 7. Okay. So when I do this, if you solve it, then you will get x, some value negative. We are not interested in the negative. You will get x equal to something like 5.6, right? So we're going to choose our k to be bigger than this. We're going to choose it to be 6. All right, so we found the value here. We found it to be 6. All right, so the final result then is what? The final result, C is equal to 1 and K is equal to 6. And you can verify. When you plug the equation, you can verify for yourself. You can see that the equation will really hold with this value. I leave it as exercise for you to do.